Hi, in this video we're going to explore how the general properties of logarithm apply to natural logarithms. At the end of the video, you should be able to rewrite base E exponential equation to natural logarithmic equation and the opposite. Also, you should be able to apply the properties of logarithm to write alternative forms of natural logarithmic expressions. Let's start with the definition of the natural logarithmic function. As defined, for x greater than 0, y is equal to ln of x if and only if x is equal to e raised to y. Now, what is ln? The function given by f of x is equal to logarithm base e of x is actually shortened as ln of x. This expression is called, or this given is called, the natural logarithmic function. Based on the definition, things we need to remember, just remember, logarithm base e of x is simply written as ln of x. The expression logarithm base e is simply written as ln. Now, if you have an exponential equation, e raised to y is equal to x can be written as logarithm base e of x is equal to y, but we don't see logarithm base e because it is shortened as ln. So you have ln of x is equal to y as the logarithmic form of the exponential equation e raised to y is equal to x. Remember, e is an Euler's constant, 2.17 and onwards. It's a approximate value, but to give an exact value, we use the letter e to represent that value. Now, how do we rewrite base e exponential equation to natural logarithm? Here is your example. If you are given e raised to x is equal to 30, you are supposed to write it in logarithmic form as logarithm base e of 30 is equal to x. X becomes the exponent, it goes on the right side of the equation. And then remember, logarithm base e is simply written as ln to shorten, or that's the other way of simply writing logarithm base e, just ln. So you have here ln of 30 is equal to x as the natural logarithmic form of the exponential form e raised to x is equal to 30. Let's have another example. E raised to 4 is equal to x is supposed to be written as logarithm base e of x is equal to 4. And so it becomes ln of x equal to 4. Last, e squared is equal to 4x is written as logarithm base e of 4x is equal to 2, or ln of 4x equal to 2. If you're given ln of 4x equal to 2, to write it in exponential form, you can change ln to log e so that you know e has an exponent of 2. E squared is equal to the argument 4x. Okay? Now, how about the properties? There are three properties, operational properties in logarithm. We have product rule, quotient rule, and power rule. How does it apply? How do they apply for natural logarithm? First, we take the product rule. Use the product rule to rewrite its expression. Assume n is greater than 0, or the number. ln of 3 times 5 by product rule, we can actually separate them with their own ln and a plus sign as separator. So you have ln of 3 plus ln of 5 by product rule. Okay? If you have here ln of 2 plus ln of 8, here we did a expansion. If we are going to write this as one value, it's called condensing. To condense, you just have ln of 2 times 8, which is the reverse. The x and y is multiplied, 8 and 2 is multiplied, 8 times 2 as 1 ln. 2 times 8 is 16. And that's it. That's how the properties apply for your natural logarithm. We are still on the product rule. Let's have one more example. If you have ln of 7n, you just separate 7 and n with a ln for each, with a plus sign between the two logarithm or between the two ln's. That's it. How about the quotient rule? Remember, quotient rule is used when there is a division or if there's a minus or difference of two the same logarithm. Let's have example. If you are given ln of 3 over 4, we can expand it using quotient rule with a minus sign. So you have ln of 3 minus ln of 4. And that's it, that's that. If you have here ln of 7 minus ln of n, in the letter A we did an expansion. To write this as one expression, or it's called condensing. To condense, we have ln of 7, ln of the expression 7 over n. Ln of 7 over n. N should be greater than 0. How about ln of 5 over 9? Well, like letter A, we will just separate 5 and 9. Each have ln, and the separator, the operation in between them is minus. So you have ln of 5 minus ln of 9. Okay. Now, you have also the power rule. The power rule says if there's a power on the argument, you can actually write it in front of the logarithm. It's just the same value. So, using the power rule, rewrite each logarithm. If you are given ln of 7 raised to 4, so you just have 4 written in front of ln, so you have 4 ln of 7. Or 4 times ln of 7. Here you have ln of x raised to 3 is written as 3 times ln of x. Now, if you have a complicated argument value like this one, ln of cube root of 4, it's easier to start first by rewriting the power into exponential fraction or rational exponent. So it should be power over root 4 over 3. And so you can now write 4/3 in front of ln. 4/3 of ln of x. That's how you write your logarithmic form with a power. Now, how do we write logarithms in alternative form? Or we're going to focus on natural logarithms and write them in their alternative forms. Use the properties, quotient rule, product rule, power rule. So, which will be the first property applied for 4 times ln of y plus 2 ln of x? The first thing you can use is your power rule. We are going to write the power in front, the number in front as a power of the argument. So this one, you have ln of y raised to 4 and then ln of x raised to 2. And since there's a plus sign, we can condense this further. We can condense this as one logarithm, and it's a multiplication of y4 then x squared by quotient rule. It becomes ln of y to the power of 4 and x times x squared. Okay, we have the last example. So you have here power rule, of course. By power rule, 2 becomes power of y, 6 becomes power of x. And to condense this one, since it's a minus sign, we will not use product rule, instead the quotient rule. If there's a minus, the first argument becomes numerator, the second argument becomes denominator. You can only apply product rule or quotient rule if you have all written the number in front of the logarithm as a power of your argument. Do that first. Do the power rule as much as possible before doing product rule or quotient rule. So by quotient rule, y squared becomes the numerator, x to the power of 6 becomes denominator. Ln of y squared over x6. That's how you write natural logarithmic expression in its alternative form. You should have learned how to rewrite exponential equation with base e to natural logarithm and the opposite. And you should have also learned that the general properties of logarithm applies the same way for natural logarithms, except that if you see ln, it actually means logarithm base e. If you need to review, you can watch this video again. Thank you.